operations that we covered yesterday, what were they? On polynomials. Okay, we discussed the degree, but we also performed some operations on polynomials, and what operations were those? Adding and subtracting. So what do we have left? Multiplication. Good. Okay, so we talked about the degree of a polynomial, and before we get started, we also need to review some key terminology. We talked about different monomials and binomials and trinomials and polynomials, and we need to make sure that we have that vocabulary in our minds. And so how do we know what a monomial is?
Because it has one term.
It has one term, and we can look at the prefix. And then for binomial, it has two, like a bicycle has two wheels, a binomial has two terms, and a tricycle has three wheels, so a trinomial has three terms. And what did we say that terms were separated by? Addition and subtraction. Okay, so go ahead and copy this example in your notes. And what property do you think we're going to use when we solve this? The distributive property. Good. And so you guys know how to use the distributive property, and we already learned about properties 2 weeks ago, or last week, on when we multiply, right? Power rules. And what did we say the power rule was for when we multiply for exponents? Add them. So we're going to take what we already know, and we're going to apply it to this. And so if we distribute 2x, what do we get? 14x cubed, good. And then minus 6x squared, good. Because our power rules say that when we multiply variables, we add our exponents. And then for the last term, what do we get? So plus 10x, very good. Alright, so we're taking what we already learned, and we're just throwing it together in a problem. And so we're going to move beyond that. Anybody have any questions on that? So what property did we use? Distributive. Good. Alright, what do you notice about what we are distributing? What kind of polynomial is that? A monomial, right? Okay. Alright, I'm going to send this one to you. Who thinks they got that one right? All right, let's see. All right. Let's see. Did everyone get this? Raise your hand if you got that. Courtney, would you mind going up to the board and explaining?
Okay, so you do -1 times 4, and so you get -4y, and then you have to add the exponents, and then you get 2 plus 1 is 3, and then you do -1 times 2 is -2, and then you add those, and it's 2, and then you do -1 times -3, which is 3, and then you have to bring the y.
Okay, good. Good job referring to these things, because we're going to hear these words over and over and over again. What are we multiplying right now in this problem? Okay, think about polynomials. What kind of polynomials are those? Binomials. When you look at the first parentheses, there are two terms, right? So binomials. And then the second one also has two terms, so that's a binomial as well. So you might want to make a note that now we are multiplying binomials times binomials. A binomial times a binomial, excuse me. And so previously we used for multiplication what property? Distributive. You think we're going to use distributive again? Why not? It's multiplication. We have parentheses.
I have a number in front.
But we have a binomial in front that we're going to multiply by. So we're still going to use the distributive property, only we have more than one thing that we need to distribute, right? Because a binomial has two things, two terms. So we have two things or two terms that we need to distribute. So what we're going to do to start off is we're going to take that first term and we're going to distribute that into that second parentheses. So that first term of the first binomial, we're going to distribute that into both terms of the second binomial. So if we do that, what is 3y times 5y?
15 squared.
Y squared. Good. Don't forget your properties for multiplying variables with exponents. All right, and then 3y times 4? 12y. So plus 12y. Now, we've only distributed the one part of that binomial, so we have a second term that we need to distribute, right? All right, so if we distribute that 2, what do we get first? 2 times 5y? 10y. And then 2 times 4? 8. Good. You guys think we're done? Why not? Combine like terms. So, at this point, what can we combine? 12y and 10y. So we bring down 15y squared. What do we get for our new middle term? 22y. And then plus 8. Any questions on that? So we're not just distributing one thing anymore. We're distributing two things because a binomial has two terms. And so you distribute and then combine like terms.
Is it considered a binomial because like they have two terms in the parentheses?
Right. This is a binomial. That's a binomial.
And then they didn't have the parentheses, it would be a binomial.
If you just had this, yes. But because we have two separate terms, it's a binomial. Good question. How many of you think you got this one right? The majority of you, good. Okay, so let's look. I think I saw one that I want to pull up. All right. So who got 8p squared plus 14p plus 3? All right. Mallory, would you mind going up and explaining?
When you multiply 2p plus 4p, you're going to get 8p squared because you have to combine, you have to add your exponents. And then 2p plus 1, times 1, is 2p. Then you go to your 3 times 4p is 12p. And then 3 times 1 is 3. Then you combine your like terms, and you get 8p squared plus 14p plus 3.
Now, this is a pretty long problem, so I'm going to give you some time to copy it. In your group, I want to hear some discussion. When you look at this problem, it says, suppose you have a piece of square fabric that has a length and width of 2x inches. The fabric is too big, so you have to cut off 3 inches from the length and 5 inches from the width. And we want to know what is the area of the new piece of fabric. So I want you to take what you know about the area of a square, or in this case, once you remove some stuff, it's going to be a rectangle. So take what you know about area, what you know about multiplying, and the data and the information that they give you, and come up with some equation or expression that you can use to solve this. Now, I want to hear you discussing that. Use what the word problem gives you.
So if for the two binomials, if you take 2x minus 3 for one, and the other one would be 2x minus 5, and you multiply those together because you multiply by the area. And then that would be 3 and 5.
So you would just do this, you wouldn't do 2 in the front.
Right. Just do those like that.
Okay. Can I get a group to go put it on the board, on the sideboard over here? Wesley?
Started off by drawing the square, and it was 2x on each side. And then he took away 3 from the length, so -3, and he took away 5 from the width. So I set up my equation by doing area equals length times width. So the length is 2x minus 3 times the width. Then you go distribute. You add the exponents. You go to the -5. You distribute the 3. I combine like terms in the middle. Got my area.
How many of you didn't need a picture? How many of you did need a picture? A couple people, good. So it doesn't matter how you get there as long as you get there. So sometimes people might need a picture. The key here were what words in the problem?
2x.
They told us 2x and then what?
Area.
We're going to cut some off, right? And if we're cutting some off, we're removing it, which is why we knew to subtract. Good. Okay. Go ahead and log out of the ClassFlow app. Okay, so what you have just received is an envelope of different strips. They're small, so try not to lose them. You have problems and solutions. And so what I want you to do within your group, and by group I mean 1 and 2 are groups, 3 and 4 are groups, so we're using shoulder partners, whoever's next to you. And I want you to match them up. So what product goes with the problem? And then, let's say I'm in this group. As soon as Taylor and Aubrey are finished, and they're finished, they're going to look at each other's and check each other's work. Okay? When you believe you are done and correct, what I want you to do is take a picture of your matches with your iPad. Okay? Alright, go ahead.
Plus 9x. Plus 14. I got an extra not x plus.
14. Here's a match. Let's put the matches on one then.
So we did this one will be x to the second. And then 7. Right. Yep. There's no more distribution. So x squared. Yeah, x squared. And then minus 10x. And then 6x. X squared minus 4. Yeah, x squared minus 4.
Alright, come to a good stopping point. I know that you probably didn't finish, but take a picture of whatever you did because I need to have something to look at what you did today. So go ahead and take a picture of what you have. You also have already received your exit ticket for today, which you will give to me on your way out, and your homework. Your homework assignment is on the board, 13 through 25 odd. And your exit ticket, and there are 2 problems worked out. I want you to tell me if they're right or wrong. If they're right, tell me why they're right. And if they're wrong, fix the mistake and tell me what they did wrong.